Okay, so our problem here is to compute the dot product of v and w, where here's v is this vector right here, and we've got the vector w. So from the way that these vectors are written, we can tell, are we in 2 space or are we in 3 space? We're in 3 space, right? Because we've got 3 different components. So we are tasked with computing v dot w, so that's how you say it, v dot w, both ways. And then the third thing we need to do is find the angle between v and w. Okay, so just to get started here, what I want to do is I want to sketch our vectors v and w. So let's see here. So I'll use a little color here. Okay, so for v, I need to go 1. So remember, the tail is at the origin, and the tip is going to be at the point 1, 0, 0. So do you recognize that this vector is I? So this is the same as I, right? And then for w, we are supposed to come 2 units forward, 2 units to the right. So I'm going to go 2 units to the right, and then 0 units up. So here we go. So that's my tip. So that is my tail to my tip. Here we go. Okay, so I've got my vectors v and w. I'll label them. Here, so this is v, this is w. Okay, and I'm supposed to compute v dot w both ways. So the first formula I have is that v dot w is equal to the magnitude of v times the magnitude of w times the cosine of theta, where theta is supposed to be the angle in between v and w. Okay. Well, in order to use this formula, I need to know theta, right? Because I can compute let's see, we can compute the magnitude of v and we can compute the magnitude of w. So let's do that right quickly. Okay, so this is my v. My components for v are 1, 0, and 0. In fact, I know that the magnitude of v is going to be 1 because v is the same thing as I, and remember I, j, and k, those standard components, they're all unit vectors. So that magnitude is equal to 1. And what about the magnitude of w? So to compute the magnitude of w, I've got my formula that I need the square root of 2 squared plus 2 squared plus 0 squared. So that'll be the square root of 4 plus 4, which is going to be the square root of 8. Okay, and I can simplify that to 2 root 2. Okay, so I'll say that is 2 root 2. So far I know that v dot w is equal to 1 times 2 root 2 times cosine of theta, where theta is the angle between v and w. Okay, so I'll be able to figure out cosine of theta once I know that angle. And since that's the second part of this question, I'll do that afterwards. Let's go and use the other formula. So we're going to come back to this. So using the other formula for the dot product, v dot w is equal to the sum of vi wi, I equals 1 to 3. That's the same thing as v1 w1 plus v2 w2 plus v3 w3. Okay, so now here I know that v1 is going to be 1, v2 is 0, v3 is 0, w1 is 2, w2 is 2, and w3 is 0. Okay, so I'm going to take those numbers and plugging them in here. Basically, to do the dot product, let me show you how I think of it actually. I think of it like this. Multiply those together, multiply those together, and then add them up. So that's 2 plus 0 plus 0. Okay, so that's really what you're getting. So we'll have 2 times 1, or 1 times 2 actually, plus 0 times 2, plus 0 times 0, and that should be 2. Okay, so we know that the dot product is equal to 2. Now let's use the fact that it's equal to 2 to find theta, right? So 2 must be equal to the magnitude of W times the magnitude of V times cosine of theta, where theta is the angle in between V and W, right? But we already know the magnitude of V is 1 and the magnitude of W is 2 root 2. So we can substitute 1 times 2 root 2, okay, for the magnitude of V and W. So now I've got 2 is equal to 2 root 2 cosine theta, and just dividing both sides, so I'll have 2 over 2 root 2 is equal to cosine of theta, and that means I can cancel out the 2, so I have 1 over root 2 is equal to cosine of theta. To make this look a little more familiar, multiply the top and the bottom by root 2. So now I get root 2 over 2. So the question is, for what theta is cosine of theta equal to root 2 over 2? And then the answer is, remember, that means theta is going to be pi over 4. So remember that sine of pi over 4 is equal to cosine of pi over 4 is equal to root 2 over 2. Remember? Okay. So we're saying that the angle, what's the angle? The angle in between these two vectors is 45 degrees, or pi over 4. Now here's something I want to show you. I wanted to show you this. This makes sense because imagine that we draw these vectors a little differently. So now imagine, so here's x, here's y. So remember, these are positive values of x, right? So positive values of x, positive values of y. And then imagine if z were coming out. So here are positive values of z, right? So what's going on here is I've got v, which is 1, 0, 0. Let me do a different color. So here's 1. Okay, so I've got v, which is here. And I've got w, which is 2, 2, 0. Now you see that since the z component, the kth component, the z component is 0 for both of these vectors, we can really look at x and y as vectors in 2D space, right? Because they're both in that xy plane. And the angle between them, that angle is going to be pi over 4. Okay, because this is 2 and this is 2. So we can form a right triangle that is isosceles. So that's going to be pi over 4. Okay.